It's storytelling time, and this story is going to be a parable that's going to help you understand artificial intelligence. But for this video, I got permission from an author who wrote a great story, and I want to adapt it to video for you. The original story, which is called A Complete Non-Technical Explanation of AI and Deep Learning, can be found right here on parand.com. Plus, he has a bunch of other good stories that are non-technical explanations, so definitely check it out. Now, follow me off to Storybook Land. Imagine this is your first day on a new job, and your job is called being a classifier. And your boss walks in and drops a spreadsheet full of numbers on your desk. Is this a cat? She asks. What do you mean? Is this a cat? I don't know. Wrong, she yells. Whoosh. Sorry, that was part of the story. The slap's part of the story. I'm reading it. I don't understand. Wrong. Whoosh. Is this the cat? Not wanting another slap, you meekly respond, yeah. Oh, correct. Good job. Here's a reward. Another spreadsheet. Cat? Slightly more confident this spreadsheet is a cat, you say, cat? Wrong. Whoosh. You're so confused. I don't understand what's going on. And why would you? She hasn't told you the rules, and you're trying to figure out if the spreadsheet is a cat, and you don't know what that means. She hasn't given you the logic to figure it out. She hasn't trained you. Correct, says the boss. This is your training. Trust me, you're gonna get really good at recognizing cats, because if you don't, you get slapped. But if you do, you get a reward that you really like, and it's really valuable. It's a square spreadsheet filled with numbers. And you contemplate those numbers, and you don't know for certain, but you throw out a guess. Is it a cat? And this goes on all day. Wrong. Right, here you go. Wrong. Right, here you go. Over and over again this happens. It's very tense, but the rewards are really worth it, and slowly you start to notice a pattern. If the sheet has mostly zeros on it, then it's not a cat. Day 2. Now this is the weirdest job you've ever had, and the slaps are terrible, but the rewards are so worth it. So you're really incentivized to start thinking, how do I get better at this? It's not really possible for one person, but if you had more people on your team, you guys could focus on different parts of the spreadsheet. Each person could look for different patterns on it. So being the entrepreneur that you are, you hire 10 people to come back with you on day 3. So at first, all 10 people are just as clueless as you were on day 1. The first guy looks like an idiot, so you go with the opposite of what he thinks. The third lady looks really responsible, so you go with what she thinks. In your mind, you assign a weight to each person. How much should I trust them, or should I do the opposite? And you eventually notice a pattern in the way all 10 people are guessing. Like if the first guy is a strong no, and the thoughtful lady is a strong yes, then it's very likely a cat. And because the rewards are so great, you actually divvy them up among all the people, and everybody's really happy. And over time, all 10 of them hone in on their opinion, because they don't like getting slapped either, and they love the reward. Eventually, your boss thinks you're super perceptive, even names you Perceptron. I almost wore this shirt, which would have made way more sense. Smash that subscribe button! Now it's day 10 and you think this is really working well. We should hire a bunch more people to help. Even though you hire 50 more people, you assign them one layer deep. Meaning the 10 people you had before now are managers, each with 5 employees under them. So now every time a spreadsheet is dropped, you have a guess, your 10 managers have a guess, and all 50 of the employees they manage have a guess. But they're getting even more accurate because they each have 5 people that they're guessing with also. And when they're wrong, you just pass the slaps whoosh, all the way down the chain. And when you're right, you spread the rewards down the chain too. But the pain of the slap when you're wrong isn't equal among everybody. So the opinion of all 10 managers of who on their team contributed the most to getting it wrong gets the hardest slap. Now this bigger system takes longer to train, but eventually the accuracy goes through the roof. And as you're sitting there pondering, watching all of these people get rewards and get slapped, you think to yourself, you know what? Nobody ever taught us how to do this. We figured it out on our own. As the final decision maker, you think all I do is pass the slaps and the rewards down the chain, weighted by who did what. And now you're getting a sense for how a neural network like ChatGPT is actually trained in the first place. Anthropic's Claude, OpenAI's GPT system, Google's Bard, they all started as clueless as you did at the very beginning of this story. But over time, looking at the data and getting rewarded or punished based on the proportion of who contributed what and having a big group of people doing it, well, that got to the incredible tools that we see today. And this process is all part of machine learning, because the machine is learning by itself. Neural networks do really well when you have a lot of data about something, like in this case, pictures of cats that were broken down into ones and zeros. But even the creators of the neural network don't know all of the rules. They can't hand code what it really means to be a cat, the essence of what it's like to be a cat. It's too difficult. However, this process of taking guesses and adjusting, that actually works really well. So now let's jump to day 40. You're pretty good at identifying cats, and it's a lucrative business, man. Those rewards are something else. Maybe I need more people, another layer of people. But you think about another layer and how much time it would take to calculate everything and adjust the slap up ratio to reward ratio all the way back, and you just settle on not doing it for a while. And then you run into some new people called the Gaming People United, or GPU for short. And they have a new way to work in parallel, meaning everybody can take guesses at the same time and there's no bottlenecks. And you think, that might work. Excited, you realize this will scale big, so you put layer after layer after layer, and you have thousands of people now that all funnel down to you. And all of a sudden, emergent patterns evolve, where some groups notice some types of patterns, some notice others, and you start to notice that the different layers of managers start to specialize in different higher and lower level concepts of a cat. And this isn't exactly something you expected, you just noticed that it emerged. But the first layer of employees, the first managers that you hired, they start to notice these really abstract shapes like circles and squares in the patterns. And the second layer starts to take that knowledge, say there's two circles, and think about how close together they are. Maybe they're the beginning of some cat eyes? And what's this triangle below it? Maybe a cat nose? Maybe? And as you go down this chain of layers, you start to realize that there's different types of cats, different positions, they're playing with different toys. These higher level concepts start to emerge. You're still sending down the slaps and the rewards, but overwhelmingly, it's just rewards. These guys have it figured out as a group, as a unit, as a team, as a system. Now, if you didn't catch it, that GPU metaphor was for graphic processing unit, which is a big breakthrough that happened in the long history of developing neural networks. GPUs got big for video games, but it turns out they're great at processing these kind of rewards and punishments throughout a neural network, with that process being backpropagation. So there you go. I hope you enjoyed Storytime. Thank you to Paran for letting me adapt his blog into this video. I really appreciate it. And if you guys want to read the full thing, there's more. In fact, he talks about convolutional neural networks, and there's other articles, which are all linked in the description below.